Assalamu alaikum all. Can you hear me? Can you hear me? Okay, let us start our today's virtual session. Today we will discuss about wireless LANs. Actually, there's some problem in uploading the slides, so I have shared the application. I have shared my screen. Can you see this figure, which is based on isolated LANs, wired versus wireless? Is it visible to you? No? Okay, let me check it again. Is it visible now? Is this slide visible? No, only chat window is visible. Okay. I don't know what's the problem. Application is shared, and if I'm trying to upload these slides, there's an error in uploading the slides. Okay. Okay, let me write it down then. It's better. Today we will discuss about wireless LAN. Now in this case we will discuss two types of wireless LAN. The first is the wireless LAN, which is defined by IEEE 802.11, and it is also called wireless Ethernet. So we will discuss about wireless Ethernet. And the second is personal wireless LAN, that is Bluetooth, that is sometimes also called personal area network or PAN. So we will discuss about Bluetooth, or sometimes it is also called PAN, that is personal area network. Now before discussing about wireless LAN, let's have a comparative study between wired LAN and wireless LAN. What is the basic difference between wired local area network and wireless local area network? So as you know that the first difference is in the medium. we can see that between a wired and a wireless LAN, the difference is in medium. In wired LAN, we uses wires to connect hosts. And in wireless local area network, the medium is air. The signal is generally broadcast. When hosts in a wireless LAN communicate with each other, they are sharing the same medium, and it is called multiple access. So in a very rare situation, we may be able to create a point-to-point communication between two wireless hosts by using a very limited bandwidth and two directional antennas. Guide and unguided. Yes, one is wireless and another is wired. Now we are discussing about the difference between the two, and the first difference is in the medium. In first case, in wired, we have a medium that connects the hosts together, which are there in a network. And in case of wireless, the medium is air and the signal is generally broadcasted. Now the second difference is in hosts. So in a wired local area network, a host is always connected to its network at a point with a fixed link layer address related to its network interface card. A host can move from one point in the internet to another point. In that case, its link layer address remains the same, but its network layer address will change. Before the host can use the services of the internet, it needs to be physically connected to the internet. Whereas in a wireless local area network, a host is not physically connected to the network. It can move freely and can use the services provided by the network. So therefore, the mobility in a wired network and a wireless network are totally different. You got this point? This point is clear? What happens in, yes? Good. Now next is the concept of wired isolated LAN differs from that of wireless isolated LAN. A wired isolated LAN is a set of hosts which is connected through the link layer switch, and a wireless isolated LAN, which is also called ad hoc network in wireless LAN terminology, is a set of hosts that communicate freely with each other. So the concept of link layer switch does not exist in wireless LAN. Now when we are talking about connection to other networks, a wired local area network can be connected to another network or an internetwork, such as internet using a router, and a wireless local area network may be connected to a wired infrastructure network, to a wireless infrastructure network, and to another wireless LAN. Now, if you will see, I don't know what happened, this slide is not loaded. Let me try it again because I want to show you one figure, then only it will be more clear. Other slides are loaded. They have no problem in loading, but I don't know what happened with this slide. What's the problem? I have to check. Let me try application sharing again. Is it visible now? Is it visible? The slide? Isolated lens, wired versus wireless? Yes, okay, good. Now see here, in this case, the wireless local area network is referred to as an infrastructure network. Here you can see we have infrastructure network, and the connection to the wired infrastructure such as internet is done with the help of a device called access point. So the role of access point is completely different from the role of link layer switch in the wired environment. An access point is gluing two different environments together. One is wired and another is wireless. So the communication between the access point and the wireless host occurs in a wireless environment, and communication between access point and the infrastructure occurs in a wired environment. Now here we have the hidden station problem. In case of wired local area network, we are using CSMA-CD. But because of hidden station problem, in which a station may not be aware of another station transmission due to some obstacles or the range problem, collision may occur, but it may not be detected. So this figure shows you an example of hidden station problem where station B has a transmission range shown by the left oval, and every station in this range can hear any signal transmitted by station B. Station C has a transmission range which is shown by right oval, and every station located in this range can hear any signal transmitted by C. So station C is outside the transmission range of B. Likewise, station B is outside the transmission range of station C. Station A is in the area which is covered by both B and C, so it can hear any signal transmitted by B or C. So this figure also shows that the hidden station problem may also occur due to an obstacle. So assume that station B is sending data to station A. In the middle of this transmission, station C also has data to send to station A. So station C is out of B's range, and transmission from B cannot reach C. Therefore, C thinks that the medium is free. Station C sends its data to A, which results in a collision at A because this station is receiving data from both B and C. So in this case, we can say that stations B and C are hidden from each other with respect to A, and hidden stations can reduce the capacity of the network because of the possibility of collision. So in order to overcome this problem, we have carrier sense multiple access with collision avoidance. So CSMA-CA was invented for wireless local area network. Now, as we have said that we will discuss two types of wireless local area network. The first is IEEE 802.11. So in IEEE, we have this project 802.11 which defines the specification for a wireless local area network, and it is also called IEEE 802.11, which covers the physical and data link layers. Now here you can see the infrastructure of BSS. BSS stands for Basic Service Set. BSS is Basic Service Set. And it is the building block of a wireless local area network. A basic service set is made up of stationary or mobile wireless stations and an optional central base station, which is called as access point. As you can see over here, it's written AP. This is access point. So BSS without an AP is a standalone network and cannot send data to other BSS. And it is called ad hoc architecture. In this architecture, stations can form a network without the need of an access point. They can locate one another and agree to be a part of basic service set. So a basic service set with an access point is also known as infrastructure BSS. So here we have seen two types of BSS. One is ad hoc BSS and infrastructure BSS. In ad hoc BSS, we do not have access point. As you can see over here, there is no access point. And in infrastructure BSS, we have access point. So this is the first type of architecture that was defined by IEEE. Now next we have extended service set, ESS. It is made up of two or more BSS with access points. In this case, the BSS are connected through a distribution system, which is wired or wireless network. The distribution system connects the access point in the BSS. IEEE 802.11 does not restrict the distribution system. It can be any IEEE LAN, such as an Ethernet. The extended service set uses two types of stations, mobile and stationary. Mobile stations are normal stations inside BSS, and stationary stations are access point stations that are part of wired local area network. So when BSS are connected, the stations within reach of one another can communicate without the use of an access point. Communication between a station in a BSS and outside BSS occurs through access point. So the idea is similar to communication in a cellular network. Now if we consider each BSS to be a cell and each AP to be a base station, a mobile station can belong to more than one BSS at the same time. Now IEEE 802.11 defines two MAC sublayers: the distributed coordination function and the point coordination function, that is PCF and DCF. Now here, before sending a frame, the source station senses the medium by checking the energy level at the carrier frequency. The channel uses a persistence strategy with back off until the channel is idle. After the station is found idle, the station waits for a period of time called distributed interframe space. Then the station sends a control frame and the request to send, that is RTS, request to send. After receiving RTS and waiting a period of time called short interframe space, SIFS, the destination station sends a control frame called clear to send, CTS, to the source station. This control frame indicates that the destination station is ready to receive data. The source station sends data after waiting an amount of time which is equal to SIFS. The destination station, after waiting for an amount of time equals to SIFS, sends an acknowledgement to show that the frame has been received. Acknowledgement is needed in this protocol because the station does not have any means to check for the successful arrival of its data at the destination. The lack of collision in CSMA-CD is a kind of indication to the source that data have arrived. Now the second type of wireless local area network is the Bluetooth, or as I have said, it is PAN, Personal Area Network. So Bluetooth is a wireless LAN technology which is designed to connect devices of different functions such as telephone, notebook, computer, cameras, printers, and they are at a short distance from each other. A Bluetooth LAN is an ad hoc network, which means that the network is formed spontaneously. The devices, that means the gadgets, they find each other and make a network, and that network is called Piconet. So here you can see a Bluetooth network which is called Piconet or a small net. A Piconet can have up to 8 stations. One of them is called primary and the rest are called secondaries. So all the secondary stations, they synchronize their clocks and hopping sequence with the primary. Now in case of Piconet, there can be only one primary station. So the communication between the primary and secondary stations can be one-to-one or one-to-many. Although Piconet can have maximum of 7 secondaries, so additional secondaries can be in the parked state. A secondary in a parked state is synchronized with the primary but cannot take part in communication until it is moved from the parked state to the active state. Because only 8 stations can be active in a piconet, activating a station from the parked state means that an active station must go to the parked state. Next we have Scatternet. Now piconets can be combined together and they form Scatternet. A secondary station in one piconet can be the primary in another piconet. So this station can receive messages from the primary in the first piconet and then act as a primary which deliver them to secondaries in the second piconet. So a station can be a member of 2 piconets. So if we talk about Bluetooth devices, a Bluetooth device has a built-in short-range radio transmitter. The current data rate is 1 megabits per second with the 2.4 gigahertz bandwidth. This means that there is a possibility of interference between IEEE 802.11 wireless local area networks and Bluetooth local area networks. Now if we see the Bluetooth layers, here we have L2CAP layer. It stands for Logical Link Control and Adaptation Protocol. So it is L2CAP, Logical Link Control. L2 here means LL. LLCAP, Logical Link Control and Adaptation Protocol. And it is similar to that of LLC sublayer in local area network, that is Logical Link Control. It is used for data exchange. And we have SCO channels that do not use L2CAP. Here you see this figure. This is L2CAP data packet format. The 16-bit length field defines the size of the data in bytes coming from the upper layers. Data can be up to 65,535 bytes, 65535 bytes. The channel ID, that is CID, defines a unique identifier for the virtual channel which is created at this level. The L2CAP has specific duties and it includes multiplexing, segmentation and reassembly, quality of service, that is QoS, and group management. Now we talk about first duty, that is multiplexing. So L2CAP, it can do multiplexing. At the sender side, it accepts the data from one of the upper layer protocols, frames them and delivers them to the baseband layer. At the receiver side, it accepts a frame from the baseband layer, extracts the data and delivers them to the appropriate protocol layer. So it creates a kind of virtual channel that we will discuss later on. Next is segmentation and reassembly. The maximum size of payload field in the baseband layer is 343 bytes. So this includes 4 bytes to define the packet and packet length. Therefore, the size of the packet that can arrive from an upper layer can only be 339 bytes. However, application layers sometimes need to send a data packet that can be up to 65535 bytes. So L2CAP divides these large packets into segments and adds extra information to define the location of the segments in the original packet. So L2CAP segments the packets at the source and reassembles them at the destination. Next is quality of service. Bluetooth allows the stations to define quality of service label. So it is important to know that if no quality of service label is defined, Bluetooth defaults to what is called best effort service. It will do its best under the circumstances. And then we have group management, which is another functionality of L2CAP, and it allows the devices to create a type of logical addressing between themselves. This is similar to multicasting. For example, 2 or 3 secondary devices can be a part of a multicast group to receive data from the primary. So this was all about wireless local area network, where we have seen IEEE network and we have also seen Bluetooth network. This was from chapter number 15. Okay, if you have any question you may ask, we still have time. Okay, regarding project 2, okay, I will ask coordinator and then let you know what you have to do. Regarding project 2, I will inform you as soon as possible. Firstly, I'll be sure about it, then I'll inform you. Yes, regarding chapter number 15 and 17, we have discussed them. Today we have discussed chapter number 15. Okay. Last week we have discussed chapter number 17. I mean chapter 17 and 19. 19? We have discussed chapter number 15, 17, 18. And in this week's virtual lecture, in this week's face-to-face lecture, we have discussed chapter number 20. So you have to study them, yes.